Welcome, guys. Okay, so since we're talking about we will talk about Shor's algorithm and the quantum computing. So I will first quickly introduce RSA. So basically, all this page is what I want to talk about RSA. So it's very short. So yeah, so be sure please subscribe to my channel. Okay, so the idea is that okay. By the way, in my usually I try to uh, simplify all the, but I try to provide all the details, but simplify the complicated things in the math and physics. So I only talk about the important points. Okay, so the idea is that if Bob want to send some message to Alice, okay, so that's called message is x. So x is just some integer. It should not be 1, right? So the scheme is that let's say we first choose PQ or odd primes. And YP is not 2, right? If you choose 2, then everybody knows you choose 2, right? Because you will compute n equals to PQ. So if n is even, then everybody choose, don't let you choose 2. Okay. So you just divide by 2, then you will get the PQ. You will get Q. Okay. But everybody knows about RSA is that so we are assuming that computing PQ to n is easy, but the factoring n go back to PQ is hard. Okay. And we will talk about how to interpret it as we talk about Shor's algorithm. And then we can compute so-called Euler phi function. Okay, so it's p minus 1, q minus 1. So idea is that, and there is a theorem called Euler Torsion theorem. And if you don't know that, you can go to my channel and I will provide a link below that you can go to check the proof. So the idea is that if you given any number which is coprime to n, then the x to the phi n divided by n will be 1. The remainder will be 1. So basically it's 1 mod n. Okay, then third that we choose E, which is yeah, so this E is called this E and N are called public key. Okay, so we choose some number which is coprime to n, and then by this theorem, so I will also provide a theorem proof in a couple of lecture. But there is this d, right, such that integer such that de is mod phi of n will be 1, right? So this d is called a private key. Okay, so now we have some number like de and phi of n and pq. Okay, so we have such a number. Okay, so the idea is that Alice had a private key d, and Bob has public key ne. Okay, so that idea is that let's say Bob want to send x to Alice, then Bob will first do the encryption. So Bob will just compute x to the power e and mod n. Okay, so this is the number, and for Alice should do the so Bob already encryption, right? So Alice should do the decryption. So basically, the decryption just take the message and the power to compute the power of d. So we get x to the de power, and by definition, de is chosen to be mod phi n will be 1. So I can write d as phi n times c plus 1 and mod n. So become x phi n to the power c x mod n, and x phi n is 1, right? So it's x mod n. So for Alice can go back to get x. Okay, so in order to make the RSA success, then Bob need to public the NE, right? So basically everybody can so that means Alice can compute. Okay, so Alice can compute D. Once Alice know E, right? Alice can compute D easily if they both know this PQ, right? Because Alice can compute this Euler phi function very easy. But if someone want to eavesdropping the process, then if someone only know n, then it's very difficult to get Alice private key D, right? The reason is that that guy do not know how to factor this n, right? That guy do not know how to factor this n. So that guy can so that one want to do the eavesdropping cannot know cannot know this Euler torsion function. So it's very difficult to get the answer if you, oh, by the way, this is capital N. So it's very difficult to factor N into PQ. So it's very difficult to compute the so-called Euler phi function. And yeah, so this is the process of RSA. So for a quantum algorithm, in order to break this skin, one idea is very key step is that someone give you a positive integer, and you need to do the factoring. And doing the factoring in the number theory is also difficult. And up to now, there's no polynomial time algorithm, classical algorithms for factoring integer, but there exactly is a classical. It is a polynomial quantum algorithm which called Shor's algorithm, which you can use this n. You can use it to factor this n into PQ very easily. So that's why we will talk about quantum Fourier transformation, quantum phase estimation, and how to deal with this guy. And I will see you guys in the next video. Hope you guys enjoy my just one page idea of the RSA.